I was saying we're going to look at how to factor something with two terms, and we're going to do that two different ways. The first is called the difference let's play around with that just a second, of squares. So think about what that means. The word difference means to subtract. So this is a situation where we're going to have one square number subtracted from another square number. So I guess we need to talk about what square numbers are. Maybe review the notion of a square number and look at some common ones. So I'm going to list down several, and I think you'll get the notion here in just a moment. 1 is a square number because it's 1 squared. It's 1 times 1. Four is a square number because, doggone it, it's frustrating. It's 2 times 2, or 2 squared. What's the next square number?
I think it would be 6.
It'd be 9. You close. It'd be 9 because 9 is 3 times 3.
Oh, okay, I see what you're doing.
16 is 4 times 4. How about the next one? 25 is 5 times 5. 36 is 6 times 6. 49 is 7 times 7. 64 is 8 times 8, or 8 squared. 81 is 9 times 9. That's right. 100 is 10 times 10. Let's do 5 more. Anybody know what 11 times 11 is?
121.
That's right. Anybody know what 12 times 12 is? 144. Okay, anybody know what 13 times 13 is?
156?
No, it's 169. There you go. That's the number for 13. If you know 13, then 1 for 14 is easy because you just switch the last 2 digits. It's 196. And then 15 squared is 225. So I usually suggest to my classes that they commit those to memory. You should know the first 10 anyway. You may know more than that. Any number beyond that, if you want to know if it's a square number, you can always just square root it on your calculator and see if you get a whole number. So that'll work. So what we're going to have here is when we have one square number minus another. That's why it's called the difference of squares. And when you have that, you can always factor the difference of squares by using this little formula. A minus B times A plus B. So let's look at what we've got here. The A and the A are what I multiply together to get the A squared. The B and the B are what I multiply together to get the B squared. Then I put a minus in one and a plus in the other. Okay? So let's use that to factor something like this. 4x squared minus 9. So if I got this problem, just like always, the first thing I had to do is ask if there's a common factor. And between 4 and 9, there's not one. And then because it's got two terms, I would ask if it's the difference of squares. So, first of all, it is a difference. I do see a minus. To get 4x squared, couldn't I take 2x times 2x?
Mm-hmm.
And to get 9, I could take 3 times 3.
So I got a factor.
So this is the difference of two squares. And here's how I factor. It's real simple. We're going to put the 2x and the 2x twice. We'll put the 3 and the 3 twice. And on one of those parentheses I'll put a minus, and the other one I'll put a plus, and it doesn't matter which one gets which. Doesn't matter. I'll just put them in that direction. Do what?
Why you put a plus and a minus?
Well, that's what the formula says to do up here, right? A minus here and a plus there. So every time when I factor the difference of squares, one of the set of parentheses is going to get a minus. The other one's got to get a plus. That's it. That's all there is to it.
And there's the M.
That's it.
Oh, wow.
So if we have x squared minus 36, is there a common factor?
1 and 1 is 1, so.
No, that's not what I'm asking. I'm asking, is there a common factor? Is there something I can factor out of both of them first? And that's right, there's not. So then the second question is it the difference of squares? And Finesse's thinking was good. X squared's got a 1 on it, so 1 times 1 gives you the 1. X times x would give you the x squared. About 36. 6 times 6. Okay, so what are we going to do? We're going to set the x up twice. We're going to set the 6 up twice.
So leave the square alone?
Yes. And put a minus in one and a plus in the other. See, if I multiplied this back out, what I'm looking for is what would I multiply together that would give me x squared minus 36.
Okay, I feel so.
So if I took x times x, that would give me the x squared.
Well, why do I say before this was
So there you go, x plus 6, x minus 6. No big deal there. Okay, let's look at a couple more here. This time, let's do 50 y squared minus 98.
This time we got a factor, right?
That's right, there is a common factor. What is the common factor? What can I take out of 50 and 98?
Well, I know you can do 2.
All right, let's take a 2 out.
You know you can do 2 if you don't do nothing else.
Let's take a 2 out. 50 divided by 2 is 25. So I'll leave 25y squared.
49.
That's right. 98 divided by 2 is 49. Okay, so we were able to factor out a common factor. Okay.
So you try to pick the two. What number you can factor out of both?
That's right. Every factoring problem you get the whole chapter, that's the first thing you do every time.
What if the number extra big though?
It might take you a while.
See, that's too much.
But are you looking for, wait a minute, are you looking for the smallest number or?
The biggest number.
You looking for the biggest number?
Yeah, but in this case, 2 was the biggest number.
Okay, got it.
Okay, now let's look inside what's left over, the 25y squared minus 49, and see if we can factor that. Well, it has 2 terms, so I'm going to check to see if it's the difference of squares. Well, 5 times 5 will give me 25. Y times y will give me y squared. 7 times 7 will give me 49. So it is the difference of 2 squares. All right, so I'm going to bring the 2 down as part of my answer. And then for the 25y squared minus 49, that'd go 5y and 5y, 7 and 7, plus and 1, minus in the other.
So you got 25 out of 50.
Uh-huh,
49 out of 98.
that's right.
Half. 2 times 49 and 2 times 25.
Yep. And that's the ticket.
So when I just can't find nothing back to both of them, I just.
You just try to do difference of squares. And if you can't, then it just won't factor. All right. Okay, so that's one way to factor when you have two terms is the difference of two squares. There is, however, another way to factor that sometimes works. It's called the sum or the difference of cubes. So this works not only when you're adding, but also when you're subtracting. Either one. Squares only works when you have difference, but cubes works when you have the sum or the difference. So I guess we need to talk about some common cube numbers. We gotta change the color here to change it up a little bit. So sometimes students don't recognize cube numbers as easily as they recognize square numbers because we don't think of them as much. But here are some common ones. 1 is a cube number because it's equal to 1 times 1 times 1, or 1 cubed. 8 is a cube number because it's equal to 2 times 2 times 2, or 2 to the third power. Do you guys and gals know the cube number for 3?
1 times 1 number. It ain't no cube number there.
3 times 3 times 3
It's gonna be 12?
would not be 12. 3 times 3 is 9.
Right, 9.
Times 3 is
27, okay.
27. There you go. Okay, here's a few more. The cube number for 4 is 64. The cube number for 5 is 125. The cube number for 6 is 216. And the next one that I would commit to memory would be 1000. I wrote that backwards of all the other ones, didn't I? I put the 6 first and the 216 second. Maybe I'll keep that consistent. 216 is the cube number for 6. 1000 is the cube number for 10.
So it goes 7, 8, 9.
Well, there is.
Oh, you just, okay.
I'm just not listing them.
I see.
So any other number, if you want to know if it's a cube number or not, you can use the cube root function on your calculator. The formula for factoring the sum or difference of cubes looks complicated, but it's not as bad as you think once you see how it works. So let me show you the formula for the sum of two cubes first. It goes like this. A cubed plus B cubed factors as follows. A plus B times A squared minus AB plus B squared. If you have the difference of two cubes, then the formula goes like this. A minus B.
Whatever we take the test, can you put them on the board?
A squared plus AB plus B squared. Usually in this class I do give you these formulas, and if you take my intermediate algebra class, I don't give you these two formulas.
Are you taking it, teaching next semester?
Okay, so I want you to notice a couple things about these formulas. Notice in both of them you need 5 things. You need A, B, A squared, AB, and B squared. You gotta have those 5 things. The two formulas look different, but really they're not. Here's what I mean. In the first one, I got a plus here in the middle. Notice in the first parenthesis, I got the same plus in the middle, but in the middle of the second parenthesis, I got a minus. So it stayed the same in the first one, but it changed in the second one. That's the same pattern on the bottom one. See, I got minus here, minus in the first, plus in the second.
So the second one only of what?
Do what?
We only use the second formula only of what?
If you got a minus here instead of a plus. That's how you know which one to use. Alright, well let's try a few sum or difference of cubes problems. And sometimes it takes a couple of these to kind of get the hang of it. So let's see what's going on here. So let's say we had this problem. 8y cubed plus 27.
You do.
So let's look for a common factor first. And on this problem, we don't see one. So if this was my test, I'd look for that first. Then I'd say, well, it's got 2 terms, so I would check to see if it's the difference of squares first, which is not, because 8's not a square number. Y cubed is not a square, and 27 is not a square. So it's not the difference of squares. Then I would ask, is it the sum or difference of cubes? And it is, because 8 was the cube number for 2, y is being cubed, and 27 was the cube number for 3. Okay, here's the key to the whole problem, what I'm getting ready to say right here. If you got a cubes problem, the first thing I would do is write it as something cubed and something cubed. I'd always do that first. And according to what I put up earlier, to get 8, we would cube 2y. And to get 27, we would cube 3.
So you doing 2y just because 2 going to 8? That's the reason you're doing it, or?
Not just because 2 goes into 8, but remember in our list up here,
Okay.
8 was 2 times 2 times 2. It was
Right,
2
that's
cubed. So that's why I chose 2.
Okay.
And I chose 3 because 27 was 3 cubed.
Right, okay.
Okay, now, why did I do that? Because now, if I look at my formula, I've got a cubed plus b cubed up here. So that means my a is the 2y, and my b is the 3. It allows me to recognize what my a and my b are. And I always need 3 more things besides those 2 things. I'm going to need a squared, I'm going to need ab, and I'm going to need b squared. But now those are real easy to figure. Because think about it. If a is 2y, then a squared has to be 2y times 2y. Or 4y squared. If a is 2y, oops, I didn't mean to do that. If a is 2y and b is 3, then ab has to be 2y times 3. 2y times 3 is 6y. To get b squared, I'm going to take my b, which is 3, and square it. 3 times 3 is equal to 9. Okay, now that I've got those 5 things, all I have to do is plug them into this formula up here. So how does it factor? A plus b is going to be 2y plus 3 a squared minus ab plus b squared would be 4y squared minus 6y plus 9. That's what we're looking for.
Oh my goodness.
Oops, I'm off the screen.
So this is I mean, you have to do all this just to get the,
Yep,
oh my goodness.
yep.
I'm totally kind of confused.
Now you didn't listen to me. What did I say to you? What did I say to you before we started this problem?
I ain't totally confused. It's just the, what you mean before you solve the problem?
Before I started this problem, I said, now these are going to take some getting used to. It's going to take a couple to see. So that's just our first one. We'll get a little bit better feel as we go here. It'll get a little better. Hang in there. Let's do another couple.
My head
Really get this stuff.
Let's go with 64y cubed minus 125. So if we're looking for a common factor, there's not one. So we got two terms. And so we ask if it's the difference of squares. Now 64 is a square number, but y cubed is not squared and 125 is not a square number. So it's not the difference of squares. So I ask if it's the difference of cubes. 64 was the cube number that worked with 4, and 125 is the cube number that worked with 5. Okay, so we're going to write it as something cubed and something cubed. That's always the first step on a cube problem. Something cubed and something cubed. And we just said that we would cube 4y to get 64y cubed, and we would cube 5 to get 125. What you just did was you figured out that A was 4y, and you just figured out that your B is 5. The rest of the problem is going to be real simple now.
Okay.
Because the other three things you need are a squared, ab, and b squared. Now class, how am I going to get a squared?
Okay, you gonna
A
do
times A, which is 16.
16
right.
y squared. Good.
So A and B, you gonna get 20y, right?
There you go. 4y times 5 is 20y. And b squared is?
It's 25.
There you go. Now throw it in the formula for minus and you're done. No, because we squared it and got 25. B
Okay.
squared is 5 squared. 5 squared is 25.
So now writing this in order is gonna be the thing. How you, okay.
Okay, if you're not sure what order, go back up here and look at your formula.
Okay, that's right.
And it'll tell you what order
We
to
doing
put it in.
subtraction, so we do, okay. 5, that'd be 4y.
Okay, so what I did was I just threw it in the formula. This is a minus b, a squared plus ab plus b squared.
Dang, I was trying to do it on my own.
No, I mean, well, here.
Oh, I messed up.
Yeah, you got it.
So we don't put the 3?
What 3?
The cube.
What cube?
Now, what we want to do with the time we have remaining is we want to look at all the kinds of factoring we've done in the last week and a half, 2 weeks, and pick a strategy for getting to the right factoring technique. Okay, so we're going to call this guidelines for factoring. And we're going to go back to these guidelines time and time again. Every time we get a factoring problem, this is the way that we're going to think now. so that we can get to the right factoring strategy on each problem. That's a little sloppy, sorry about that. And basically, we're just formalizing what we already know, what we've already said, and here's what we've said. Step one is always going to be, is there a common factor? I'm always going to ask that question first. Sometimes there will be, sometimes there won't be, but if there is one, we want to factor it out. Okay, and then the next step is always going to be how many terms. How many terms are there? If there are 4, we do grouping. Sorry. If there are 3, we'll use the AC method. And if there are 2, we're going to check if it's the difference of squares first. And then if it's not that, we'll check to see if it's the sum or the difference of cubes.
That's for 1.
Do what?
That's for 1.
That's the one. No, these are both for 2. We'll check to see if it's the difference of squares first, and if it's that, we'll factor it as such. If it's not that, then we'll see if it's the sum or difference of cubes. We don't have one. You can't factor something with one term. Okay, so let's try to see if we can get to the appropriate place on this problem. 2m squared minus 10m minus 48.
I think these are some of the problems with homework.
Aha, that's right. It is. So in this problem, is there a common factor? So when I look at 2, 10, and 48, they all have a common factor of 2. So I'm going to take the 2 out. 2 out of 2m squared leaves m squared. 2 out of 10m leaves 5m.
Okay, that's why I was getting mixed up then. I wasn't doing a common factor with all 3 of them then.
2 out of 48 leaves 24.
Okay.
Okay, then we look in here and see what we have. We've got 3 terms. So we're going to try to factor that by the AC method. Now, this particular problem we can use the shortcut on because it's got a 1 on the squared term. Okay, so 1 times negative 24 is negative 24.
So you, okay.
If you square root 24, you get 4 point stuff. So 4 is the first number we're going to check. 4 does go into 24 6 times. So either 4 and negative 6, or negative 4 and 6. But neither one of those add up to negative 5, so that's not it. So let's check 3. Is 3 going to 24? It does, 8 times.
Right.
So either 3 and negative 8, or negative 3 and 8.
So it's a negative 8, 3 and negative 8.
That's right. Adds up to negative 5. So what's my answer? I've got my 2. I've got m and m.
And you get 3.
Plus 3
3
and minus 8.
minus 8.
Boom.
Okay, that's what I don't know, I guess I'm getting all, I guess I can get all mixed up on this. So you had to find the common factors for 2, 10, and 48.
Yep.
Okay, I wasn't doing it, I was doing it
Yep.
for 48.
And then when you got all of that,
But don't you do one of them like that, you just find for one, just for one of them?
Nope. Anytime you're looking to factor out a common factor, it has to factor out all the terms.
Oh, I thought it was,
so you find the factor 24, because that's the biggest number.
No. Another one or two here. If I gave you 5 plus r minus 5s minus rs.
okay, my head hurt now.
I would look for a common factor first. And in this case, there's not one. And then I would count the number of terms. How many terms do I have here?
You got 3.
Nope. You've got 5, you've got r, you've got negative 5s, and negative rs. So you got 4 terms.
Oh, okay.
So we're going to do grouping. Group the first 2, group the last 2.
I would've missed that one then. I was looking at the,
So out of 5 and plus r, we can take a 1 out. That's the only thing we can take out. That's going to leave 5 plus r. Out of negative 5s and negative rs, I can take an s out, but I'm going to need the signs to flip because I'd like to be left with another 5 plus r. So I'm going to take out a negative s. Negative s out of negative 5s leaves 5. Negative s out of negative rs leaves r. And now my 2 parentheses are the same. So I'm going to end up with 5 plus r times 1 minus s.
I get a little bit confused on those, when they just 2 letters, you know.
And so I'm about out of time. So really the only kind of problem that we didn't look at today was an AC method where we couldn't use the shortcut. Everything else we looked at. So here is an assignment for you. We got some difference of squares and difference of cubes problems. So on page 387,
Oh, wait.
10 through 12, and 15 through 18. And then you're also going to need to do some sum or difference of cubes problems. So I think 61 through 66 would be some good ones there.
So these are the problems we just did today?
Yes, ma'am.
Okay.
But then on page 390, we got those problems where we throw all of them in together. And that's what you really need to practice because that's what your test is going to be like.
On 390?
Yes. So let me give you some there and then we'll add to it next time. So on that page, start on number 11. And you can go through number 23 and do odds. And then you can 25 through 31 odd. And then we'll shut it down there on that one. Okay.